Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, as you can tell from my cabana wear, it's summer, and all summer long we've been covering the new modular controllers, the new CPUs from Horner Automation, and we're going to do that again today. But today we're going to go beyond just the new CPUs. We're also going to talk about applications that also affect our all-in-one controllers, like the Micro Series, Canvas Series, etc. Let's take a look at our topic for today. CPU and OCS-I CAN wiring. When I say we're going to go beyond the topic, basically I mean that regardless of what type of Horner controller you have, if you want to expand your system using OCS-I, we've got good information for you today. So without further ado, let's get to it. Before we get started with our content today, I want to remind you that later this week, in just a couple days, on Thursday, we've got the big launch of the next new modular controller that we're releasing at Horner this summer, and that is the CPU 300. And along with that CPU, we'll also be releasing a series of HMI Connect displays that you won't want to miss. So check out the public launch webinar this Thursday. Now, you do have to register for that. I've got the link on the page, and you can also check your email. You were probably invited, if you're on the Horner mailing list, you were probably invited to the webinar with an email. So don't miss it. Okay, now for our topic today. How are we breaking it down? Well, we're going to do a quick review of CAN port functionality. Okay, what are we using that CAN port on the Horner controllers? Mainly, we're going to be talking about I/O expansion today. That's primarily our topic. We're going to talk about the different types of connectors for CAN that are used on Horner controllers. We're going to talk about different types of wiring you can use for CAN with Horner controllers and Horner I/O. We'll talk about making those connections, and there'll be plenty of demonstrations throughout for different installation scenarios. Okay, let's do a quick review of CAN. Now, what is CAN for those of you who are unfamiliar? Well, CAN stands for Controller Area Network, and it's a specialized chip that was invented many years ago that enables robust and reliable communications. Okay, now, it's very popular in both industrial automation as well as automotive. So popular, as a matter of fact, that literally billions of these chips are manufactured every year. Some of the chips are dedicated. Some of the chips have this functionality, included in microprocessors, microcontrollers, that sort of thing. Now, why do you need CAN in a world with Ethernet? Well, CAN is simpler and more robust than Ethernet and requires less bandwidth. So it definitely has its place both in automotive as well as industrial automation. And at Horner, we utilize it thoroughly. All right, how does Horner utilize CAN? Well, we primarily use CAN for two functions: easy I/O expansion of all Horner systems and peer-to-peer communications between Horner controllers. Okay, and to accomplish that, we invented our own protocol on CAN called C-SCAN. Okay, and it's been around for a while. It's very easy to use and very robust. As a matter of fact, you don't even think about the protocol. You just connect up your I/O and use it, or you connect up your controllers and have them start exchanging data. Okay, now, in addition to I/O expansion and peer-to-peer communications, Horner also supports some standardized CAN protocols, including CAN Open and J1939. CAN Open is an automation standard, very popular for things like servo controllers, and J1939 is an automotive standard. And we have plenty of customers that are using Horner controllers either in their factory to test their mobile devices or even on mobile devices themselves. Now let's start talking about how you can make that connection with CAN on Horner controllers. And we're going to start with the connectors. Horner controllers have two different style connectors that they use for interfacing with CAN depending on the controller. Let's start with open terminals. Open terminals is the most flexible way of connecting CAN in that you get a terminal strip included right on the CAN port on the Horner OCS or on the I/O block in the case of some of our I/O series. And in most cases, it's a double plug like you see there on the screen at the upper left. So you can easily make connections for a CAN coming in and a CAN going out. Okay, so that's included in a lot of our products. I'll tell you which products here in a second. Now, some of our newer products and some of our products that are physically smaller, instead of using the open terminal block, which takes up a little bit more space, they use an RJ45 jack. And this not only facilitates smaller space, but it also facilitates using category style cabling or Cat5 or Cat5e style cabling with CAN. Okay, and that reduces cost and reduces labor. So that's a relatively new development in the last few years. Now, which Horner controllers use which connector? Well, you can see that the Canvas and the XL Prime series, along with our traditional XL series, they use the open style connection. Okay, and then the Micro series, as well as OCS-I and the new CPUs, they use the RJ45 approach. So that kind of is a quick breakdown visually for which controllers use which connector. Okay, now let's start talking about cabling, because not only are there two different connectors that Horner uses with CAN, there's also two different cable styles. Let's start with CAN specific cable. Okay, so this is cable developed specifically for CAN, and there's some different varieties. We'll talk about that in a little bit, but all three varieties were designed for CAN. Now, what does that offer you? Well, it gives you the most robust solution to take advantage of all the noise immunity that CAN can offer, and it gives you clearly defined specifications for distance, the number of nodes you can put on a network, and baud rate. Okay, so you get a lot by using CAN specific cable. However, not all applications really need that extra capability. So that's where category cable comes in, Cat5, Cat5e. This is more convenient, easier to install in a lot of cases, although it does have more limitations. It doesn't have the distance capabilities, the number of nodes, and those sorts of things, but we'll talk about those specific limitations here in a minute. Okay, now when we take a look at the conductors and the pinout for the two different types of CAN cabling, let's go through that now. All right, so when we're talking about CAN specific cable, we're talking about 5 conductors. We have a red and a black wire that can be used for power delivery when used as a pair. And then the black wire or the V- conductor is also used for a common mode reference, okay, because these nodes can be separated by some distance. All right, you also have a blue and a white pair. All right, that's the actual CAN communications pair. All right, now I didn't mention this before, but the red and black pair is twisted, and the white and blue pair are also twisted. All right, now in addition to that, you have a shield drain, which is a bare conductor. All right, and that has to be handled properly in order to achieve the noise immunity that that shielded CAN-specific cable can offer. Okay, all right, so that's the CAN-specific cable, 5 conductors. Now, in the case of the Cat5 or Cat5e, when you're using that with CAN, we're really only talking about 3 conductors. We don't use the power conductor because we don't distribute power over Cat5 or Cat5e with CAN. All right. We also always use unshielded Cat5 or Cat5e, so there's no shield to deal with as well. All right. We just have the CAN pair, CAN high and CAN low, which is the orange pair when you're talking about category Cat5, Cat5e wiring. And then there is the common reference or green-white, okay, the V- pin. All right. So even though there's 8 conductors within that cable, we're only using 3 of them. The orange pair, which is 2, and the green-white reference, which is 3. Now let's talk about some of the limitations with the 2 different types of cable. Now I mentioned before with CAN-specific cable, there are 3 different variations. So depending on the variation, you get a network distance of either 100 meters, 300 meters, or 500 meters. You can have as many as 64 nodes per segment. You can also use repeaters to expand the number of nodes up to 253. All right. You can do power delivery up to 4 amps. And from an EMI RFI noise protection, it's the absolute best. Now, if we look at the category 5/5E cable, which is we always use unshielded with CAN, the network distance is limited, 33 meters, which is still about 110 feet. We can do up to 8 nodes on that network, okay, safely. It does not do power delivery, as we mentioned, and its EMI and RFI protection is okay. because the conductors are twisted, so we do get some benefit from that, but it doesn't have the best, really top level of EMI RFI protection that we have with CAN specific cable. All right, now let's talk about termination, because unlike Ethernet, with CAN, when you are connecting devices over CAN, each physical end of the network has to be terminated with approximately 120 ohm resistor, okay? And we have at Horner 3 different methods of doing that termination. All right, let's go through the 3 different methods now. All right, so if you're using open style plugs, it's probably going to be convenient for you to use a physical termination resistor, and we include 2 in the box with every Horner controller that has an open style plug, okay? And those are 121 ohms. All right, so if you're using open style plug, that termination resistor might be the most convenient. Now, if you're using a product that has an RJ45 jack, it's not easy to get a resistor in there, right? So we have added software termination. In other words, either within your program by turning on a system bit, or in your system menu by going to a specific entry in the system menu, you can turn on what we call software termination. That is a software switch that puts a 121 ohm resistor into the circuit at the right place on the OCS. Okay, so that's your second method of doing termination. And then finally, if you have a Horner product that has 2 RJ45 ports on it for CAN, an in and an out, we now include an RJ45 terminator plug in the box with those products. That would be the OCS-I bases, for instance. Now, we haven't always done that, and you can also purchase these plugs separately if you choose. I've got the part number there in the lower right-hand corner for that particular accessory, but it does come in the box now with OCS-I bases. Now let's talk about making those connections, because we've got 2 different types of connectors and 2 different types of cabling. So the first question we get quite a lot is, if I'm using an OCS that has an open style connector for CAN, can I use Cat5 cabling? The answer is absolutely yes. You can certainly do that. And in a few minutes, we're going to go through some scenarios in which you would do just that, and we're going to show you how to do it. The other question we get is really the converse of that. And that is, can I use traditional CAN cabling with an RJ45 style jack on my controller or IO drop, and how do I do that? And again, the answer is yes, and there's a couple ways to do that, and we're going to show you how to do that here in a minute. Okay, now what we're going to do for the rest of today's topic is we're going to go through a few different installation scenarios and kind of demonstrate on the bench how you might handle those from a wiring and connectivity standpoint. All right, so let's start with our first scenario, which is a simple scenario. We have a single control panel. We've got a micro OCS X7, which is the main controller for the machine. And we are using OCS-I inside the same control panel to expand the I/O capacity of the machine, okay? And any CAN wiring we have for the system is all internal to the cabinet. So that's our first scenario. So let's see how we would handle that on the bench. Okay, so this is our simplest scenario where we have 2 components. The CAN wiring never leaves the enclosure, and both components support RJ45 for CAN. So we've got our X7 with its CAN port connected to our CNX OCS-I base, connected to its RJ45 port. In this case, it turns out that a 3-foot or 1 meter RJ45 patch cable works perfectly. All right, and then of course we can't forget about termination. In the case of OCS-I, we have our standard termination plug. And in the case of the X7, we have either in logic or from the system menu, we need to turn on termination that is enabled in software. Of course, we only do that if the X7 is on the end of the network, which it is. And of course, we only terminate the CNX if it's on the end of the network, which it is. For our next scenario, we've got a little more complex situation. This time we have 2 control panels. A main control panel housing the micro OCS X7, which is controlling the machine, and a second control panel with OCS-I installed that's located remotely closer to where the sensors and actuators are located, providing the I/O capacity for the machine. These two control panels are 25 meters apart, which is not too far, and we don't have any significant EMI or RFI concerns with the machine, so we're going to use category-style wiring, Cat5 or Cat5e. So let's take a look at this scenario on the bench. Okay, for this remote panel, we're using category or Cat5, Cat5e wiring from panel to panel, and we happen to be using a bulkhead connector that has RJ45 on both sides. So on the outside of the panel, we have an RJ45 connection. On the inside of the panel, we have an RJ45 connection. So we've got a standard patch cable, this time a 1-footer, coming from the bulkhead connector to the OCS-I base. And once again, we have our terminator plug to make sure this end of the network is properly terminated. In this scenario, we still have category 5 or category 5e coming in, but this time, instead of coming in through a RJ45 bulkhead, it's just coming straight through a traditional gland type connector or something like that to get cable entry. And the 3 conductors for CAN are just being landed on this field terminal strip. And then we've got this pigtail of an RJ45 patch cable that we cut off and also connected to the field terminal strip. So in this case, again, just using traditional field terminals, we'll need 3 of them, 1 for CAN high, 1 for CAN low, and 1 for V minus, in order to go with this approach for category wiring all the way through. For our third scenario, we have a very similar situation as number 2, but this time our 2 control panels are separated by greater distance, and we have some concerns about extreme EMI and RFI in the application. So instead of using category style cabling, we're going to use traditional CAN cable. Now, when we go to the bench, I'm not going to be talking about grounding at all while I'm demonstrating how to make the connections, so I'll cover that before we go to the bench. Now, when you're using CAN style cable, it's very important to handle the shield drain properly on the CAN cable. Now, in this sort of application, the way we would typically handle that is we would ground the shield drain of the CAN cable usually at the main control panel, because that's usually where we have the best earth ground. Okay. Now, if the better earth ground was somewhere else, we would ground it on that end instead. But either way, we would only ground it at one place only. All right. Now let's go to the bench and take a look at how we make the connections. Okay, now we're moving into some scenarios where we're going to start using CAN wiring as the interconnection between the OCS and this remote panel. Okay, now why might we use this traditional CAN wiring instead of Cat5 or Cat5e? Well, it could be because of distance. CAN wiring can go much further. It could be because it's a tough environment for EMI RFI. So in those scenarios, really tough noise environments, CAN wiring is superior. So those are a couple reasons we might do that. Now, one of the approaches we could take would be to bring the CAN wiring in through a cable gland and then connect it to the field terminal strip. And again, in this case, we've got 3 connections, CAN high, CAN low, and V minus. And once again, we're taking the pigtail approach into the CNX base with those 3 conductors again, also connected to the interposing terminal strip. So this is one approach for solving that, and we've got another one. Okay, here's the other solution I was talking about for interfacing traditional CAN wiring with RJ45, and that is this new breakout adapter or pigtail, depending on how you want to consider it. It allows you to take the 8 pins on the RJ45 port and break them out on 8 terminal strips, numbered 1 through 8. So that works really nicely with traditional CAN wiring. Now in this case, we're not running power along the CAN wiring. We're just running CAN high, which is white, CAN low, which is blue, and V minus, which is black. Now it is feasible that we could run up to 4 amps of power and take advantage of the red conductor in this cable bundle here. But if we did that, we would not connect the red cable to this terminal strip here. We would connect that red conductor to the field terminal strip, or maybe even directly to the front of the CAN I/O base. So anyway, this is a different approach for interfacing traditional CAN wiring with RJ45. For those of you interested in that new accessory I just showed you, the part number is there on the screen. It's a brand new product for us. You can purchase it on our web store or from one of our distributors, but keep in mind, because it's a brand new product, they may not have it in their system yet, but definitely a useful accessory. Now for our final scenario, we're going back to a simple situation where we have a single control panel with an OCS all-in-one controller controlling the machine and OCS-I/O located on DIN rail in the same enclosure handling expansion I/O. Now in this case, remember the canvas features an open style connector for CAN, and as we know, the OCS-I/O features RJ45, so we need to interconnect these two inside the panel. Now, instead of showing a video clip, I'm just going to talk about how we solve this. One easy way to solve this is to purchase a cable from Horner that's already built that interconnects an open style CAN port with an RJ45 style CAN port. And it's available with the part numbers you see on the screen at the lower right in two different lengths, 3 feet or 9 feet. But of course, you could also build this cable yourself by taking a standard RJ45 patch cable and cutting it to length and connecting it to the open terminals block that's included in the box with your OCS. And I'm showing the pinout there on the screen. Okay, that does it for our content for today. Don't forget to sign up for training. We've got 2 classes left this year in the 4th quarter, and they're starting to fill up. So go online and reserve your spot today. All right, still plenty of trade shows that Horner is going to be participating in, and we're just in the 3rd quarter, and look at all these particular trade show options. You can see us in Chicago at WEFTech. You can see us in Houston. You can see us in Lake Buena Vista, Florida, Odessa, Texas. Lots of options to come see a lot of these Horner products in action and talk to some Horner folks. Okay, you can interact with us online at hornerautomation.com, on our YouTube channel, or on LinkedIn. Okay, this is my final reminder. This Thursday, 2 days from now, we've got the big launch of the CPU 300, which is the next modular controller available from Horner, and we're concurrently releasing HMI Connect displays to go with it. It's a really exciting product launch, so don't miss it. You'll have to register on Big Marker. We've got the link on the screen. Now next week, once we've introduced the CPU 300, we're going to go hands-on with this device and show you how it works on the bench. We're going to give you all kinds of good practical information for utilizing the new CPU 300 modular controller along with HMI Connect displays. If you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, or hopefully until this Thursday, if you join us for the big CPU 300 launch, let's all get out there and do some good.